Okay, folks, so quick video, balancing equations. It doesn't tend to give you a ton of marks in the exam. However, those 1 or 2 marks can make a difference. So, let's start off with this question. Now, it says BeCl2, which is there. This is how the question was given. Is heated with potassium. So we're going to put potassium there because them two work together. And what do we get? So the products are always on this side. So we end up with beryllium and we end up with potassium chloride. Obviously, I've just written these two down. In the exam, so in question, they did not give you these two. But obviously, we have a periodic table. So you just look up the table. You find out that potassium is K. And then you find out that beryllium is Be. Yep, so let's just substitute everything in. So forget about balancing for now. This is there, this now goes there, because them two are heated together. And then what do we get? Beryllium, so we put Be. And then we get potassium chloride, which they've given us the symbol as KCl. Now what we do is we want to balance the left-hand side with the right-hand side. So put down all the different elements you have. So we got beryllium. That's your first thing. Second thing, we got chlorine. And third off, we got K, which is potassium. So this is on the left-hand side. Let's do the same for the right. You got beryllium, chlorine, and potassium. Now let's look at how much of each we have. We only have one beryllium there, Be, so we just have one of it. Chlorine we have 2, and potassium we just have 1. Now on the other side, so on the right-hand side, we only got one beryllium for now, 1 chlorine, and 1 potassium. So as you guys can see, beryllium is fine 1 and 1. Potassium is fine 1 and 1. However, chlorine, there is double the amount on the left-hand side compared to the right-hand side. So to fix that using mathematics, very simple. We just have to multiply this by 2. Yeah, so we have to multiply the chlorine by 2, whereas the chlorine is found there. The only catch is in chemistry, you cannot just put a 2 there. This is like the most fatal mistake you can make. If you put a 2 there, that's wrong. The only way you can multiply something in chemistry is by putting the number in front of the whole compound. So you have to put the 2 there. I know what you guys are thinking. You do not want to target the K, because K was fine and happy, right? They were balanced. All you wanted to target was the chlorine. However, that's life for you. So you target both of them. Now your chlorine becomes 2 because 2 times Cl is now 2Cl. However, and you guys know, we also had to times the K by 2, right? So now K is also 2. So now that means we have to now fix this K there. But it's kind of simple because K there is by itself. You just put a 2 and voila, it also becomes 2. So now we have one beryllium, 2K there and 2K there, and then 2 chlorine and 2 chlorine, because this 2 is multiplied by everything. So it's like 2K and 2 chlorine, if that makes sense. Yeah, so the 2 is multiplied by everything behind it. If I wrote, for instance, 2H2O6N3, right, something complicated like this 2 will be multiplied by H. H already has a 2, so 2 times 2 means we have actually 4 H's. And then 2 times oxygen is 2 oxygen, but there was 6, so 2 times 6 is 12 oxygen. Then 2 times nitrogen is 2 nitrogens, but times 3 gives you 6 nitrogen. So as in, this just kind of shows you how much of each we have. The 2 is multiplied by every single thing behind it. Okay, let's do the next one together. So these are all 1 and 2 markers. So let's look on this side, left-hand side, right-hand side. Left side, we got P for, well, I have no idea what that element is. I think is it potassium? No, it's not potassium, it's phosphorus, I think, maybe. P, and then we have O for oxygen. How many of P do we have? We have 4. How many oxygen do we have so far? We got 2. Now we also need to put on the other side. Here we have 4 P, but we got 10 oxygen. So the P's are fine. The oxygens are an issue. Now in chemistry you cannot divide, so let's not pull any stunts here. You can't do this divided by 5 because then after you just everything goes crazy. So just multiply the smaller one to get it to be the same as the bigger one. So we need to multiply this by 5. So I just put 5 there because it's by itself. So now you have 10 oxygen because 5 times 2 is 10. You got 10 oxygen there, which is good, and then 4 and 4 P's, which is fine. Yeah. Okay, next one. Once again, what we got P, O, and H. We also got P, O, and H for both sides. On the left-hand side, we have 4P, 10H, but add another one. So there's 10 and one more. Don't forget that one, 11. They're both on the same side. They're both on the left-hand side. And then H, we just got 2. So this one already looks problematic. 11 is not a number I like seeing. This one, don't let it fool you guys. The big number is multiplied by each small number. So, like for example, hydrogen already had this 3. So you do 4 times 3, which means you have 11 hydrogen. Sorry, what kind of maths is this? That's embarrassing. Sorry, 12. 4 times 3 is 12. And then you got 4 times just 1p by itself. By the way, guys, these small numbers are only for the letter they're attached to it. So this 4 is not for P, it's not for H, it's just for the O. P has no number with it, so it's just 4 times P, which is 4. And then 4 times 4 gives you 16 oxygen. Okay, now we got a lot of things to kind of balance out, and we can only change this. Now, to be fair, guys, in the exam, because chemistry, they're not expecting to be a mathematician. If there's only one fill in the gap, you really and truly, you can just probably start with like 2 in your head, and you can kind of figure out that if you put 2 there, 2 times 2 means you now get 4 hydrogen there, but they're interested in what, 12, right? So to get 12 hydrogen we need to put what, 6, right? Do you guys agree with this? Because 6 times 2, so if we times this by 6, you get 12. So 12 and 12 on both sides are fine. But now the thing is, the 6 affects the oxygen, right? So if we were, let me change the oxygen. Let's say the oxygen there was 10 plus the oxygen there, which was 1. Just, to make it easier, which was 11. So we're not going to change this oxygen. This 6 only affects that oxygen, which means 6 times that will make it 6. So now 10 plus 6 is actually 16, and voila, they're balanced. Yeah, so it looked hard, but to be fair, guys, you just had to put a number which basically made both this and this catch up to them too. So I just focused on hydrogen first, which was simple because, you had to begin with. You needed to get 12. You just times it by 6, and you put the 6 there. All right, next one. We have GE, which is, you guys might be saying, how do you know if they're not 2 different elements? An element always starts with a capital. So if you got lowercase, it's still part of the same element, whereas this is another capital. So this is one element, then that's another one. So GE, you got O, and then you got H, and then, oh god, and then you have Cl as well. Do I even have enough space for this? I kind of set myself up. All right, so we got 1 GE, 2 oxygen, 1 hydrogen, and 1 chlorine. Let's do the same for the other side. They'll be a bit more wary this time. And then H. So we got H, and then we got Cl. Okay, so let's look on the right hand side. You just got 1 GE, you got 4 Cl, you got 2 hydrogen, because 2, and then you just got 1 oxygen. So let's see. Let's focus first maybe on fixing the chlorines. Okay, with chlorine, you can see that there's only 1 here and 4 there, right? So let's just say hypothetically, you put 4 here, right? So you put 4 there. So that means your hydrogen now becomes 4. And your chlorine also, you times it by 4, so that also becomes 4. So chlorine and chlorine are happy now. Let's look on the other side. We still have to fix hydrogen and oxygen, right? Because if you guys think about it, this side has double the oxygen in that side. So just times this by 2. So now this oxygen becomes double, which is good. But then again, think about it. We also times the hydrogen by 2. So 2 times 2 is 4 hydrogen. So this side now has 4 hydrogen, which is the same as that. And bam, done. Easy. Yeah. I'm going to go to this one. So aluminium, and then, so let's write what we have. Aluminium, oxygen. Never write it with the actual 2, just by itself. Write the same thing on the other side. How many aluminium do we have, guys? We got 1. Oxygen, we have 2. And on the other side, on the right hand side, we have 2 aluminium because there's a small 2 there. And we have 3 oxygen. We need to balance it. Okay, what we can do is, if we want to make this, the problem is they didn't give us any fill in the blanks there, so we cannot really do much there. All right, let's see. Hold up a minute. What? Did I wait 1 second, guys? I think this question is copied down wrong or something. Where are you hiding? All right, almost there. Almost found it. Okay, oh, whoops. This was meant to have a blank there as well. Okay, so yeah, we can fill stuff in. So let's try to get this to basically become 2. And I'll show you what the issues are here. When you have odd numbers, life becomes a bit difficult. What I would always suggest is, for 1 and 2 are the easiest numbers to deal with. Focus on this right now. Now, what I like using is lowest common multiple in maths. You want to make both of these have the same common multiple. Now, both 2 and 3, the easiest thing to do, times them together, gives you 6. So you want to make both of them get 6 each. So to get this side to get 6, you need to times it by 3, and do the opposite there. To get 6 there, you need to times it by 2. Yeah, so on this side, we're basically going to times this by 2 because you want to get the oxygen to become 6. So 2 times the 3 oxygens becomes 6 oxygens. And on this side, you want to make the oxygens 6 as well. So we have to times it by 3. So you put 3 there. So 3 times 2 gives you 6 oxygens. And on the opposite side, 2 times 3 also gives you 6 oxygens. So my advice is always focus on the stuff that had the really weird numbers. Whenever you see 2 and 3, I guarantee you they want you to make sure both sides are 6. That's just how it works. So that's fine. Now, last but not least, aluminium. This is very easy. How many aluminium do we have on this side? Because 2 times 2. So now the aluminium is actually 4. So if you have 4 on this side, we also want 4 on this side. It's very easy. Just put 4 there because by itself doesn't affect anything else. Done this by 4. And bam, done. Yeah. So I hope this was pretty good for you guys. And yeah, I'll attach a link to some questions which you can try and answer as well. Peace.